My name's Keith Rucker. Today we're back out at the Georgia Museum of Agriculture and working on the next project on restoring the J.A. Vance planer master that I've been working on now for about a year and still have quite a ways to go to. Today's project is going to be working on this gear. I say today's, it's probably going to actually take me several days in short bursts that I have time to work on this, but this is one of the drive gears that drives and powers the feed rollers on the milling machine or on the planer masher. And unfortunately right here, one of the teeth has been broken out. This happened probably when the machine crashed at one time in the past. There's several telltale signs of a crash that took place on this machine. I think that a board got stuck going through the feed rollers that wouldn't turn anymore, but the gears were still turning, and eventually this gear here broke, along with some other damage that was done to the machine that we've been having to repair during this restoration. So the game plan for this is we're going to come in here, we're going to actually mill off this old tooth, come in here and make a slot with an end mill, and then using a dovetail bit, come in and make a dovetail in the back of this that we can then make a new tooth and just slide right into that dovetail key and put on there. We're going to be doing this on the horizontal milling machine, mainly because we have a small gear and a large gear side by side. We can't get in here to work on this on the vertical mill. Plus you have to mount it in the machine like this, which is not going to be very rigid. On the horizontal mill, I can work on it laying down flat like this, coming in from this side here. And it's going to require making a special arbor to hold my cutting tools and using the overhead, one of the outboard arms to give it support and rigidity while we're doing that. But this is going to be a great job for using my my horizontal milling machine on. So first step is we're going to take this piece here and make a little jig or fixture that we can put on the milling machine to mount this. So I'm going to turn this down to the same diameter of this bore in here, and then I'll bolt this to the table and then slide this down on there, and I can clamp it down and be able to get a good rigid fixture to hold it in place. So first step is we're going to be working on this. Once we get this tooth done, we'll also have to come in here and press out the old bushings, put some new bronze bushings in here. This is the shaft that this goes on here, and this is very pitted from years of use, and this is 1.25 inches in diameter. And when I measured, I mic'd out this the bushing, the inside bushing, is actually 1.44 inches. So it's actually worn almost 200 thousandths, this bushing has. So we'll be pressing this out and actually making a new shaft because this is pitted here. So we got quite a bit of work to do on this piece to get this brought back to life, and that's what we're going to start on today. First thing we're going to work on here is making this jig to hold it in place. So we're just going to start out by taking a center drill, punch that in there, drill a 1/2 inch hole about 5 inches deep in here. Then we're going to turn this outside down to that 1.440 diameter that the gear can slide over, and then that'll give us something we can clamp down on the table. We'll cut this off and face that off flat, but that'll give us something we can clamp down on the table and mount that gear to. So we'll get started. within about 60 thousandths of our final dimension here. This piece has gotten pretty warm, obviously cutting off, doing pretty heavy chip removal. There toward the end we were taking about 80 thousandths total per pass, so 40 thousandths on each side. So I'm going to let this cool down a little bit because just the heat that's in the part right now can cause it to expand, and when it cools back down to ambient temperature, the final dimension can change by a few thousandths. So we're just going to let this cool down. We'll come back and we'll finish this job in a little bit. Okay, we've let this cool down, and now I'm just going to measure it again out of curiosity. And we were, let's see, that shrunk 4 thousandths of an inch just by cooling down. So we've still got about 54 thousandths to take off of it. So we'll just sneak up on that number. Try it on here and make sure it's going to fit. Alright, it's fitting on both sides. There's actually 2 bushings in there, and they must not be perfectly aligned. For the purpose of just giving us a guide to hold this on, I'm actually just going to turn it down a little bit more and make it fit. We're going to clamp everything down to the table to make it rigid. This is just kind of to give us a guide to help set it up on it and give it a little bit more rigidity. So I'm going to take a little bit more off. Perfect. We have our holding fixture made now, and I'm going to try it on the milling machine. So I've got a just a T-nut slot here, or T-nut with a long piece of rod in there. We'll slide that over it like such, and then on top of that we'll come in and put the gear, which fits down on there very nicely. I'm going to make a special clamp to go on the top, but for right now I'm just going to take a hold down out of my clamp set. We'll put that on there just to try her out. And get that started. Tighten it down. Now I have a very rigid way to mount this gear to the milling machine that's going to work very good for us to come in here and mill this out. So step 1, making the holding fixture. Success. We're ready to move on to the next step. We've got everything mocked up here now just to kind of show you what the game plan is for next. So we've got this built now that we can hold the gear in place. I've just got it setting here now. It's not bolted down yet. But we've got to get a cutter into this section right here. And because of the way this gear is, the way it's sticking out, it's going to be really difficult because there's just not a lot of clearance in here to get a arbor right up there next to it. Normally we get this right up next to the chuck or put it on the vertical mill and do the same thing, but because of the size of the quill on the vertical mill, we just can't get in here. So my idea is I'm going to build an arbor that will go from here and it will extend out to here. I've got this overarm support right here that will give this some support out here so that that shaft can go over the long gear, but we'll be working close not to the chuck but to this overarm support here to give us the rigidity we need with our cutter so that we're not flexing. So the overarm support is mounted on here. Everything looks like it's going to clear just fine. But we've got to make an arbor to go through this. So I have a bushing inside this right now that will take it's 3/4 inch. I know that my cutters that I'm using have 3/8 inch shanks on them. So my idea is I got a piece of 1.5 inch bar here. We're going to turn this down to 3/4 inch, except up here on this end, which will drill and ream a 3/8 inch hole right in the middle. And this will actually become the chuck that will hold my cutters, and it will just stick out right here and give us enough room in here that we can work and get done what we need to do. And then we'll have this will be turned down to 3/4 inch to go up into the arbor on the mill. So that's the game plan. So next step here is we're going to make the arbor that will be used here. We've got the piece of steel set up here in the lathe now. We're going to come in and just do a center hole, drill it out to one size under 3/8, and then use a 3/8 reamer to ream that hole out for our tool holder. And then we'll just put a face on this end, which will be the working end, and then we'll flip it around and start cutting the other side. Hopefully you guys can see what's going on now. I'm limited on camera angles because of the way this lathe oriented, but I'm hoping you can see this. But I've got the compound set to 45 degrees because I want to actually cut the leading edge off this off. So we'll face this and then cut a 45 on there. Hopefully I got enough room to work here with the camera. All right, we flipped the part over. Now we're going to face off this side and put a center in it as well. This will be the back side. The side will be turned down to 3/4 inch. We're getting everything ready to turn between centers. I've got a dead center mounted in the chuck. But because this chuck has some run out, and even if it doesn't, you've got a pretty true running chuck, you're always going to have a certain amount of run out in it. So I always just take and freshen this up every time I do it to make sure that I've got a perfectly running center on the drive side. So I have my compound set to 60 degrees, and we're just going to go here and clean this up real quick. The arbor now mounted on the lathe between centers. Turning between centers is kind of a, I guess, an art in machine shop world that has been somewhat lost with the advent of CNC machinery. But back in the old days, this was a very common practice, and it still has a very useful function for certain applications. In this application, I've got to make absolutely sure that the shaft that I'm turning down here is exactly on center with the hole that I've drilled into the other end that my cutter will go into. So to do this, I've got this machine set up between centers. The hole, of course, is in this center. I've got the shaft in the other center. There's a little bit of run out in it now, but of course I'm going to turn all that out. Turning between centers is also very useful if you need to flip a part over and keep everything running true. No matter what kind of chuck you have, You're always going to have a little bit of run out unless you take the time to indicate it in on a 4-jaw chuck, and even then you're probably not going to have it running just absolutely perfectly true. Turning between centers, you can get around a lot of that. So with this going now, my shaft that I'm going to turn in here 3/4 of an inch will be exactly on center with the hole that we drilled and reamed earlier. So we get to work. We've got this turned down now to about 25 thousandths over. I did stop at that point, and actually I went down, grabbed some lunch, and came back. But the main reason was it had gotten pretty warm. I was taking about a 40 thousandths cut off of this once I got going and kind of figured out what I could safely take with this cutter. And so that was taking 80 thousandths total off the diameter each pass. So we're taking some pretty good meat off of it. And as you can imagine, it got fairly warm to the touch. And again, just like when we were making the fixture to hold our piece on, when it gets hot like that, it will actually expand just a few thousandths of an inch. And because we need this to be very close to exactly 3/4 of an inch, I wanted to let it cool down. So that's what we did there. So what I'm going to do now is it is cool to the touch. We're going to come in here and just finish this out. I have the bronze bushing that is out of the Arbor support on the milling machine, and I'll be testing the fit with this. It really doesn't matter what the diameter that is. The main thing is that it fits in this bushing just right. So we'll be checking that fit as we get down close to the end. We've got this Arbor set up on the milling machine now, and we're going to come in here and mill a flat right here on the end, and this is where this Arbor will go into the tool holder on the milling machine, and there'll be a set screw that engages here, and that'll keep it from marring up the shaft where we can get it in and out. We're also going to come down here, drill a hole in here, and tap that for a set screw that will then be used to clamp down on the tool that we put into the Arbor. You go ahead. Okay, we flip this around in the vise, and now we're going to find the center of this and pop a hole in there and drill it and tap it out to 3/8/16. So first thing we got here is our center finder in here. We'll turn this on. I like to run that at a pretty good RPM to drop that down. So it's just testing there. I have my digital readout turned on, and we're going to bring this in until that piece jumps over. Boom. That's right on the edge of it. I'll zero out my digital readout. I'll back out, and I usually do this at least twice. And that's within 2/10,000ths of an inch, so we're going to call that right on the edge. Now to find the center of the shaft. I know that this is a 1/2 inch in diameter, so first thing I'm going to do, instead of having the edge running just right up to the next edge of this, I'm going to move it over to the center, is right on the edge of the part. So that means I need to bring the table to me a quarter of an inch, half of a half inch, would be 250 thousandths. So again, using my digital readout, I'll pull it over there, and there I am at, whoops, 250 thousandths, right on the money. I zero out my digital readout, and now I want to get this to, instead of to the center of the edge, into the very center. I know that this is 1.5 inches, so again, half of that would be 3/4 of an inch, which is 750 thousandths. So I'm going to move it over again, 750 thousandths. And playing with it, getting it just right. There it is, 750 thousandths. I'll re-zero out the readout again, and I lock my table in place. Now I know this is right in the center. I could have just moved it all 1 inch. I've been a quarter of an inch plus 3/4 of an inch, but I typically like to zero out the edge finder. It just brings less error into everything. Instead of trying to add it together and make sure the sum of the two is right, I'll just zero it out. It's easy enough. So we're set up there. Now let me put a center drill in here, and we will get a drill center right there where we want it. As you can tell, I'm at the museum today, and it's Saturday, and the train's running, our steam locomotive, as you can hear, running around the tracks. Alright, and I'm going to move that over just a little bit to about right there, and I think I grabbed the dull one again. Let me flip it over. Much better. Alright, that's got me a center to work off of. Put my drill bit in here. And we'll pop that through. Okay, I'm now set up with my tap. I'm using a little spring-loaded center up here that keeps everything right in line. Unfortunately, this tap does not have a center hole in the end, so I had to put this tap handle that does on there, which caused me to have to drop my table way down. But that's just the way it is. We'll put some tap magic around there, and this just helps make sure that as you're starting this, that tap is staying perfectly straight up and down, which is so easy to start a hole out and get it crooked. Once you get it going, it's really not necessary that you have it the whole way down, but it does help you get it started right. That taps all the way through. Almost done with this piece. The last thing I'm going to do is we're just going to turn this nose piece down here a little bit. We've made it out of 1.5 inch stock. I measured one of the tool holders on my 40 taper or 50 taper tool holders off the milling machine, and this was 1.25 inches, so we're going to just turn that down to the same diameter. Probably don't have to, but we're just going to do it anyway. we have everything set up over here on the milling machine now. I just made a first test cut just to see how things are going to go. Quite honestly, I forgot to get the camera set up, but we're going to bring you in here now. I've got a 1/2 inch end mill in here, and the first thing we got to do is just kind of cut this old tooth out. We're actually going to mill a slot down in here that we can come back and cut our dovetail key after we cut that slot first. So we're just going to be feeding this in a little bit at a time, and then we'll raise the table up to actually make the cut. As far as feeds and speeds go, let's see, right now we're running the bit at about 250 RPMs, and I have my feed set right now on the slowest possible setting, and I may play around with this as we go through here and see how things are cutting. But right now we're feeding it at a 1/2 inch per minute. So it's a fairly slow process right now. Like I said, I'm going to play around with these feeds and see if we can speed things up just a little bit. But I like the way that was cutting right there. We have an interrupted cut right now too, so I'll probably start out slow and slowly feed in there. So, but looks like things are going pretty good. I've got this centered where that tooth is, and I'm going to be cutting out. And again, I'm just going to be feeding straight in and making a slot down through there that I will then cut our dovetail out with in a later step. And we'll get going. Even though we went to a lot of great pains and effort, I do have a little bit of run out on this Arbor after everything's said and done. But it's pretty slight, and I think it's going to be fine for what we're doing. We're going to go with it regardless. We'll go about there. What I'm doing right here is I'm actually getting my first full depth cut. Because of the overarm support right here on the gear, the first couple of cuts, I had to stop shy of going all the way to the bottom. But now we have it out where it's going to give us that clearance we need, and this is as far down as I go. Now the next thing I need to do is I need to rig up an indicator or something along those lines that I can watch to be able to tell where I get to zero each time in this cut, so I can stop in the same place. So I'm going to take a break right now, get my indicator out, and see if I can rig something up to be able to watch the depth of this cut each time. Alright, here's what I rigged up. As you can see, I got an indicator set on 0 there. And that's basically where I just stopped that last cut. So that's my reference. What I did was I mounted the base of the indicator to the machine itself, and I rigged up a little stand that goes down to the saddle, which is going up and down with that feed. So that this bottom piece basically will come up, it will engage the indicator, and I've got about 90 thousandths of travel to be watching for as it comes in there to stop it, to be able to keep it from hitting bottom each time. And I'll probably just get it close and then raise it up a little bit by hand to finish that out. So this should work pretty good for me. I looked at a couple of different options. I started to say, well, I'll just indicate off the top here, but then I got to thinking that the table's going to be moving in and out, and that might change my bearing surface for 0 each time, not by a lot. But this way, working off the saddle, there's nothing moving on that saddle except up and down. There's no in and out moving on it at all, so I feel pretty comfortable with that. I'm not crazy about these arms sticking out, but there's plenty of clearance around. Shouldn't be anything hit them, so I should be good to go. And actually, it's all choked up pretty tight down here, so I won't be having a lot clay in that indicator, and then that would be going down to the base there, just with another magnetic holder that I had that I just rigged up. I welded a little piece on top to give it something to indicate off. We'll give this a try, see how it works. We have our groove cut deep enough, so now while we're still in this setup, I'm going to put the dovetail bit in, and we'll put the dovetail bit so it's basically touching the bottom of that cut, and we'll make one pass down to the same depth and cut the dovetail in there. My total depth of this cut is about half the thickness of the hub, which is kind of about where I want to be. It's not an exact measurement. I'll measure it after we get it all out and figure out how deep it is, and then make the gear, the new tooth, to fit that. But this should be ready to go for the dovetail cut next. Okay, we have the dovetail cutter in there now. I've got it set to the same depth as the last cut we went down, and we're just going to cut down through there, and this will just kind of cut the shoulder out of the hole of the half-inch slot we've already cut down through there. Okay, that's looking good. I'm going to put the regular end mill back in there now and just kind of clean up the rough edges around here and clean the bottom up. I didn't want to do that until I get everything done, so this dovetail will be running exact center of that slot. But now we're going to clean up around it to get that tooth down in there real good. Alright, here's a view down the dovetail, and you can see what I'm talking about. We've got just a little bit of a, right in here and over here, it's just a little rough surface. I want to just clean that up. Then also down here at the bottom, where that end mill was going in, an arc, we're going to come in here and just trim that down flush with this back piece. Just cleaning it up. Okay, now we've got this turned around here, we can really see what we've got. So you got that dovetail slot. It goes down through there. It actually doesn't go all the way to the bottom. We weren't able to get it down there because of the way that it was, but we've got enough of a dovetail there that we will have more than enough to keep that tooth from pulling out as it's torquing around. So I'm going to call this part of the job done, and the next challenge is going to be to make a new tooth that we can just slide down in there and either solder or braze in place. I haven't decided yet how I'm going to permanently affix it, but at least we've got something to work with now.